Hey, you guys. I got a question for all of you. It's too dirty on this table. Don't you guys all want to know about math and science and all that stuff? Doesn't it just make you happy on the inside? Yeah, that's good. Today I'm going to teach you about the Taylor series and all this stupid stuff. You know, I hate how regular math works. You know? When did it ever have to be sigma this and sigma that? You know, I think once you see the decompiled version of the sin x, you're gonna love it. Everybody loves sin x. Okay? First, we start off with sin x minus x3. No, you stupid. Stay still, sin x, x3 over 3 factorial. And then when you continue the pattern, you do plus x5 over 5 factorial. And basically the concept here is x, let's say x equals pi over 2. You know what I mean? So, pi over 2. Anyways, all I'm saying... Ooh, look at moth. Okay, kids. Don't you want to learn about sin x? You know what? Sin x is boring. Everybody knows the Taylor series, power series, whatever you want to call it. Basically, you know, sigma... Sin x equals sigma whatever. Who cares? Sin x equals sigma 2x. It's too abstract, you know? It's not something humans are really meant to do, I feel like. I feel like humans need something a little bit simpler, eh? Like, come on. When did math have to be so hard? Why can't... Oh, come on, get out of here, bug. Stop crawling on me. Get out of here. All I'm saying is, the Taylor series, power series, it's all very interesting. But maybe you guys are more interested in some more generic coding. Like, who doesn't want to learn some PowerPC assembly? All that stuff. Everybody loves PowerPC assembly. Okay, that's good enough. Let's put the marker. The marker is fallen. It's okay, we'll grab it later. You guys want to know how to make a function in PowerPC assembly? All you have to do is start out with the store word update. What the store word update does is it pushes the stack pointer by a certain amount, say negative 0x10. It's very fun instruction, store word update. And then we have to get the move from link register. Let's say I put the move from link register into R0. The reason you use register 0 the reason you use register 0 and not other registers is because register 0 is actually, it's not a fully functional register in the PowerPC architecture. The reasoning for this, for example, is some instructions exist, such as load immediate R3, like 1. The thing about load immediate is that it's actually technically just addition. If we decompiled this, load immediate is technically just addy R3, R0, 1. The issue is, if every instruction that was load immediate actually cared about the value of R0, you'd basically be unable to set values to anything, because instead of doing, like, making R3 equal 1, you'd basically just, like... you would just add R0 to 1, and then it would be impossible to do anything. So how the PowerPC architecture is set up is that R0 is forced to basically just always be considered as the value 0 in this mathematical equation. And there's other situations for this too, such as load word 0, where if you try to take a word from the register 0, like in memory, it'll break too. Now, I'm not actually too sure why it breaks with load word 0, R0, but it's probably just something to do with the low-level CPU interpretation of register 0, because all the other registers work fine. Basically, instead of move from link register R0, you could do R1 to Like, you could basically do it with any instruction, but we use R0 because it's so useless, basically. And so because it's useless, we basically use register 0 to hold the data of the link register. And maybe this is a lot to talk about, but when you call a function in, say, a high-level language like C, you don't actually have to worry about the stack update and the link register and stuff. The reason... Okay. Okay. So the reason... Okay. Okay, so anyway... Okay, all we're talking about today is, it's scary. Anyways, all I'm saying is... Come on, Marker, get over here. Okay. I think I've taught you all enough about PowerPC for... They're at... Oh, God. Oh, God, why is this the world we live in? Chaos winds blowing everywhere. You'll never get a break in this reality. Oh well, thanks for watching.